So, good day everyone. So again, we are here to do a comparison between the derivatives of these two functions, where in the first one we have y is equal to e raised to x, and the other one is y is equal to x raised to e. So again, I think one of the questions here is which of this function we can apply the power rule, and let's try to solve them one by one and see how will be the approach for each function, the derivative of its function. Okay, so let's try the first one. Y is equal to e raised to x. So if you would remember your differential calculus, so the derivative of e raised to u is actually the same as e raised to u du. Okay, so in other words, here your u value is x and the derivative of x is 1. So the derivative of dy over dx is actually equal to e raised to x, okay, e raised to x. So this is actually the derivative of our first function. But if you will try to apply what we have learned yesterday, so you can also prove that the derivative of y is equal to e raised to x is also e raised to x. You can apply this this method where you can take the logarithms of both sides. So that means you have ln y is equal to ln e raised to x. Okay? So therefore, you can apply this one, you can apply the properties of logarithms here, wherein this exponent here can be placed here. So ln y therefore is actually equal to ln e raised to ln e, sorry. Okay? But then again, if you will see here that ln e is actually equal to 1, so therefore ln y is equal to x. Okay? So taking the derivatives of both sides, so that means 1 over y dy over dx, and then the derivative of x is simply 1. So therefore you have here now like 1 over y dy over dx is equal to 1. So just cross multiply the y there. So dy over dx is actually equal to 1 times 1, which is y. But then again, the value of your y is e raised to x. So dy over dx is actually equal to e raised to x. So we arrive with the same answer here, which is e raised to x. So this is actually one way to prove that the derivatives of e raised to x is actually e raised to x also. Dx, of course. Okay. What about the second function? Okay. So x is x raised to e is actually e here is a constant. So that means you can do the power rule. Okay. Wherein, or you can apply the power rule. So we're in the value of your e is actually somewhat like 2.718. So if you will apply the power rule here, so what do we have? So dy, the derivative of u raised to n over dx is actually equal to n u raised to n minus 1 du. Okay? So this is our general formula. So e here exponent, so that means you have dy over dx. So you can apply the power rule. So e x raised to e minus 1. So therefore, our final answer here is actually dy over dx is equal to e times x, e raised to e raised to e times x raised to e minus 1. So this is the answer here. Okay? So I think most of the students, this is where they get confused. Okay? So you can only conduct, or you can only apply power rule if you have a variable raised to a constant. But if you have a constant raised to a variable, so it's a different scenario. It's a different approach of derivative. Okay, so this is the difference between the two. So I think that's it for now, and we will do more on the following days. So again, don't forget to hit the notification bell and of course subscribe and watch the succeeding videos. Until next time guys, bye-bye!